Hi, I'm David. I'm one of the engineers here at Skip, and today I'm going to be giving you guys a demo on protocol-owned builders. So, what is POB, protocol-owned builders? Well, it's a new Cosmos SDK module that we are calling the Builder module that enables users to participate in a transparent, permissionless, fair, and open auction for top-of-block execution. What this means is a user such as myself can take my transaction alongside other transactions that I want to group together in what we call a bundle that I can then take to an auction to bid to have all of those bundled transactions execute at the very top of the block sequentially as I give it to them before any other transactions are executed for that block. Why POB? Well, in short, we at Skip very much push the entire thesis of sovereign MEV. And sovereign MEV is the idea that application chains should be sovereign and have the right to determine where and how MEV is created and how to distribute that MEV to its delegators and so forth. So POB is very different from other block-based markets, primarily PBS, because it is directly implemented into the protocol as opposed to having to rely on off-chain builders to create the flows and auctions necessary to permit me to execute bundles top of block. So how is POB configured? There are a few parameters that you can set, including the number of transactions that can be included in a bundle, the bid floor for an auction, the fee to enter an auction, the delta fee, in other words, how much greater each subsequent auction bid must be in order to be considered in an auction, whether or not you want to have front running and sandwiching protection, and whether or not you want to distribute a certain portion of the auction revenue to the current proposer. So in this demo, we are going to be using the Cosmos SDK's simulation application to demonstrate how any sovereign application can potentially integrate POB directly into their application. So there are going to be three scenarios that we're going to walk through. The first one is going to be a top of block swap. Second one is going to be a top of block back run. And then the last one is going to be a top of block front run. So how do users actually participate in this auction? Well, the way that they do so is by submitting a special transaction that includes a single message auction bid message. And within this message auction bid, what you are going to include is your bid alongside the bundled transactions referenced by the actual transaction hash. So we can see the parameters that are currently set for the node that we are running. We have a bundle size of 2, escrow address, which is the address of the auction house that's going to be accruing all the revenue. And we also see that we have enabled front running protection, which is going to be important for this demo. So on the right, we have a simulation application node running. Then if we go ahead and attempt to do the first swap, first auction transaction. So we can see that we create a new transaction that is a single message that has a swap. And then we also create this new message that wraps around this transaction. And the expected order of the transactions is the bundled transaction first, and followed by our swap. The reason why we first put the auction transaction at the very top is in order to ensure that the auction participants are actually charged by the auction house and that they pay the fees necessary to actually have the right to be at the very top of the block. And we can see that this is the expected order, and we can see that when the block itself was actually created and processed, that the order matched, and that the balance of the auction house has actually also increased. So we can try this second scenario. So in this scenario, we are attempting to do a back run. So we can see a swap from a different user. We're back running that with our own swap. Then we have the bundled transaction. These are two separate transactions, and this is the bundled transaction, the auction transaction, I apologize. And we can see that this is the expected order. We have the auction transaction, we have the other user's swap, and then we have our swap. And we see that when the block was processed, that the order matched exactly what we'd expect it to be. And we can also see and verify that the auction house also got the funds. And in the very final example, we're going to attempt to do a front run. So since front running protection is enabled, we expect this to not be able to be processed. And we see that we have our swap followed by another user swap. This is the expected order, and we can see that when we broadcasted the bundled auction transaction that it failed because there was possible front running or sandwiching attack. And that is everything for this demo. Thank you so much. Take care.